Okie doke. All right. Let me just make sure everything is working on my end before we start. All right. Let me just make sure everything is working on my end before we start. All right. Just make sure. Let me just make sure everything is working on my end before we start. Well, okay. I was getting an audio feedback loop there. How's it going, everyone? I believe we are currently live and things appear to be going nicely. That audio or that video quality is a little meh. I changed some stuff in the streaming software, so I'm still fiddling with it. But let me see if I can make this look a little better before we start. Well, no, actually the stream quality is looking halfway decent. Hello, John. Thanks for joining us. Now, before we begin, just making sure, for those of you who are here, how is the audio and the video quality for you? Because I can change a few things before we begin if it's not good enough. Volume a little low. Cool, because I can in fact adjust that. Testing. Let's bring this up. Let's see. How's the audio now? Because I can bring it up. I don't want to bring it up too much to the point where it starts clipping. Because I do have a visual indicator of how loud the intake of the audio is, but it does take some fiddling with. Still optimizing the software. All right, video's good, volume is good, cool. All right, now I know I didn't give as much notice to this live stream as I would have liked to. My schedule as of lately has been very hectic, but I've been definitely meaning to do this stream for a while now. And I'm glad that I finally have some time to do it, albeit it's a little late at night, but at least it's a weekend. Now then, we're looking at some more stuff on AliExpress for 3D printers. And I figured, considering linear rails and the such are very popular for an upgrade for your 3D printer, we could talk about linear rails and the various kits that you can get for your printer to use linear rails instead of V-slot rollers. Because there's actually a lot of downsides to using V-slot rollers, but there are some interesting products I know of that can turn your little rollers into an all-metal system. I've never used them personally, but I figured, why not talk about it? So, sitting here, we got AliExpress up on the webpage. Got some iced tea. Albeit I need to refill my glass. Got everything phasing in and out as usual because RTX video and RTX voice is on. Hopefully the audio is okay in terms of quality. I do have my microphone sitting nice and close to me now, as opposed to at a distance when I first started doing this. But Let's get on into the show here. And remember, if you guys have something interesting you found on AliExpress that you want to take a look at that's 3D printer related, you can always post a link to it in chat. I will pull it up on my end and see if it's something we can talk about. As long as it's appropriate, and within YouTube's guidelines, I don't see why we couldn't talk about it. Keep this stream interactive and fun because I like talking and I like discussing stuff. So I figured, why not start this whole thing off with Highwind? Now, for those of you who are new to linear rail stuff, Highwind is the name brand linear rail that everything else is based off of. Highwind is based in Taiwan, and they make precision constrained motion instruments such as this dovetail style linear rail. Now this is an MGN12 linear rail, and there's various different specs, but most 3D printers will be running MGN12 and MGN12 carriages and MGN12H rails. I may have those backwards, but these things are pretty beefy, and basically all these holes right here are all the way through the rail, and you would put a screw with a T-nut on the back of it, and that would bolt to the frame of your 3D printer. And that allows you to get that same linear motion going back and forth or up and down, however you want it, in a constrained path that is very, very reliable. Now, linear rails are fantastic. They're not maintenance free. So you do have to consider that a linear rail, I haven't done a stream because I've been a little under the weather as of late, but I'm getting better now. Linear rails are still a metal on metal system, so you do need to add some sort of lubrication to the rails in order to make sure they're working properly. Now, linear rails, the reason it's metal on metal is because you've got these ball bearings that are moving in and outside of the housing and the inner groove of the linear rails. So that's what's metal on metal, but the movement is very precise, especially when you compare it to something like a V-slot roller, like on your Ender 3, where you got to adjust an eccentric nut and stuff. Those eccentric nuts need to be adjusted once in a while because of the wearing of the rubber on those little wheels on your stock printer. Whereas a linear rail doesn't really have that issue. It is going to be consistent throughout the majority of its life so long as the parts are lubricated. I personally use Super Lube. It's a PTFE based lube that is just okay. First off, Super Lube is awesome for like so many reasons. If you've never looked into Super Lube, and you know what, let's pull up Super Lube real quick, because it is something that everyone should have in their arsenal for their 3D printing applications. It is a synthetic grease that is, in fact, made in the good old US of A. And this stuff is good for so many different things. So this is Super Lube. Now, it's kind of cut off on the side, but it's in this little tube. And dude, when it comes to 3D printers, I promise you, this tube will last you quite a long time. This tube is just, you shmoo a little bit of this on the various parts of your printer that are metal on metal. So your Z-axis rod, your lead screw, that, give it some Super Lube. If you're running linear rails, put a very thin film of it across the rail itself and run the carriage back and forth on it, and it'll distribute the lube through the ball bearings. And this stuff is just fantastic. You can use it for so many different things. It's a good lubricant. It's a good dielectric grease. It's I mean, we'd be sitting here for a while talking about this if I went into everything you could use it for. Stuff's amazing. It's great for working on cars too. So you have to excuse me blowing my nose a little bit because there's going to be a little bit of that. A little bit of that getting over a small head cold. But linear rails. So everything that is a linear rail is being compared to Highwind. Highwind is the brand that sets the standard for most industrial and, in this case, consumer applications for whenever you need to have a system that is moving in a single direction. So we've pretty much covered that. But what about the, like, for instance, knockoff brands? Oh boy, here we go again. Two Trees. If you guys were with me last stream, you'll know my rant about Two Trees and how much I really don't like the products that Two Trees puts out. But linear rails are one of those things that, for better or worse, I don't know if Two Trees I would buy one from them. Give me just a second, guys. I'm actually going to pull up my stream on another window. And so that way I can keep track of the comments, because eventually we'll be getting into them. So Jen is saying, I got some ceramic ball bearings to replace the bearings in my MGN12 rails I ordered. When I got the rails, they were already pretty smooth, so I'm not sure I'm going to replace them. So I've actually never looked into ceramic ball bearing replacements, but I can see where that would make sense in some ways. Well, I'd have to look into the advantages and disadvantages of the ball bearings, because most of the ball bearings are typically some sort of stainless steel. They are a ferrous metal. So they're usually not aluminum. I've never run into any of them that are aluminum ball bearings. And I know it's a ferrous metal because I've had magnets stick to the ball bearings, because when you install linear rails on a 3D printer, God help you if that linear rail slides off the rail, because those ball bearings are held in by the rail. So if the carriage comes off, say goodbye to your ball bearings. I've had that happen, and they go everywhere, and they're so small, and yes, you can get replacements. I learned the hard way, you know? There's ways to prevent that. You can get little rubber stoppers that sit in between the actual little spots in the rail to prevent the carriage from coming off. Or, as someone once told me, you could just use a zip tie and put it through the hole. And tie that for temporary purposes. Actually, hold on, I think these might be exactly what I'm talking about. Yeah, okay, hold on. Yes, here we are, the little rubber stoppers. Yes, you put these, well, no, these just make it flush. Are they? They look flush to me. There's little red ones you can get. And I'm not seeing the red ones, but so you can get these, and they basically sit in the same holes, but they're much more higher up, so that way the carriage doesn't slide off during installation. Because you have that's a problem. Now, that being said, you can absolutely get replacement ball bearings. You just got to make sure you get the ones that are the right diameter. And in fact, one of the things you can do to make a cheap linear rail carriage work better is to take a carriage like this, which is generic and probably not that well machined. Their tolerances can be a little meh. But you can take them and remove the ball bearings that they use in there, because in order to make these things cheap, one of the things they do is they use really shoddy ball bearings where their diameter is not super consistent, and these are really tiny little bearings, right? So you can get better ball bearings to put in cheap linear rail carriages, and that can help them work a lot better. And for what it's worth, I have a 3D printer, an Ender 3, with genuine Highwind rails and Highwind carriages, And I also have one with generic MGN12 rails and MGN12H carriages. And in the grand scheme of things, I actually haven't noticed a real quantifiable difference that can be seen in 3D printer usage. Um, so with that being said, there's definitely good generic rails, right? You don't have to get high wind because high wind stuff is really expensive. So if we go to any of these, right? Let's look at MGN12. And oh, you can get ones that ship from the United States. But let's go from China for now. 300 millimeter MGN12H. Oh, these are not high wind. Ah, they almost got me. They almost got me. So this is something you're going to run into, right? You're going to see these right here, and it is the same color scheme as Highwind brand linear rails, but they are not Highwind linear rails. Genuine Highwind linear rails will have laser etching along the rails telling you the model and spec of the linear rail, as well as laser etchings on the carriages. So those who are new to linear rails might look at that and think, "Oh, that looks like a Highwind linear rail," but it's not. It's not. It's a knockoff linear rail. Let me see. Well, let's get some actual, real, genuine Highwind in this discussion. So 300 millimeter, okay, MGN12. Okay, so for one axis, let's say this is just your x-axis on a standard Ender 3. It's going to cost you approximately, and I think no, it's free shipping, but there is actually still tax when you buy on AliExpress, and that's almost $50 for a rail set for just one axis. Now on the Z-axis, you're going to need two of them, one for each side. And on the Y-axis, there are some designs for the Y-axis that use only one linear rail, but I'm personally not a fan of that. And we'll actually get into those linear rail kits in just a minute. I just want to talk about the rails first. And so I use dual linear rails on my Z or my Y-axis because I think it's actually quite important for stability. And in terms of load-bearing purposes, you're going to be fine because these things are designed to carry actually a pretty decent load on them. But in terms of like preventing wobble from vibration, I think the dual Y-axis setups are better, but obviously that's very expensive because then for one axis on the Y-axis you're paying $100 for a linear rail setup. Now that's if you're going with Highwind. Like I said, you could definitely go with the other brands, the knockoff brands, and they're mostly okay. The problems you might get into with the non-Highwind stuff are things like these screws right here, where you would like bolt your carriage plate to hold your hot end and stuff. Those might not be as deep, or they might be deeper than usual, or they're offset between each bolt or between each hole is a little bit off by even like maybe a millimeter or two, and that's when you start getting into issues where compatibility with things that are already designed might be a problem, because most things are designed around the name brand. The copycats, they're not always great at maintaining the specifications required. So that's the only time we actually have issues. So now that we've talked about the rails, let's talk about the linear rail kits, because there is so much to talk about. Let me pull up a linear rail kit. And we're going to start off with the good old Ender 3 because that's what I'm familiar with, and that's what I can start telling you about. So we're going to type in Ender 3 linear rail kits on AliExpress, and I am going to pull up... You know what? We're going to pull up two things here. We're going to pull up two different forms of Y-axis linear rail kits, and we're going to discuss the differences between them because I think this is where thinking ahead about what it is you're buying really pays off. So let's go back to here. All right. So this one's from BVL, and this one is from Firmware, which, man, I don't think I'm pronouncing that right, but I personally have the one from Firmware, and this is a dual Y-axis kit. Now, the reason that I went with this kit is very simple. It uses the stock frame to mount to. It uses the stock Y-axis carriage. And that means that any accessories that you build around the frame will be compatible with anything that is designed to go on the stock frame and the stock carriage. There's a lot of different things out there that rely on you using a stock part. And this type of carriage doesn't change anything to the point where you can't use it. Now, I do see they have updated their... Or, no, actually... That's right. My Y-axis kit didn't come from Funseer. Mine came from printer mods. And I had some problem with printer mods because the holes on the left and the right for mounting to the plate on the Y-axis carriage were too close together, and the screw and the holes were just a little bit farther apart, so I had to shim the carriage plates, the carriage plate mounts, so that they would screw in properly. Otherwise, the screws, instead of going straight down, would come in at a corner, and that would bend the linear rail carriages a little bit on their on the rail, and that would cause binding. So there's little things like that you got to think about. But everything I've ever gotten from Funseer in terms of their linear rail kits have been good. I really like their stuff because they use the stock rail. Now, this is what I like to see, but there are other options because, again, this is a dual dual linear rail for a single axis. So that can get expensive if you're going like a genuine high wind rail route, right? So just blow my nose real quick. There we go. Now I don't sound so nasally. This is BVL. BVL is a very, very well-known manufacturer of linear rail kits for Ender 3s. But let's discuss the differences here. First off, this is not a standard Y-axis plate for an Ender 3. You got a lot of different holes, and it's all proprietary to the system that they have designed. So, we got a single Y-axis linear rail kit, and it attaches like this. So still on the side of your Ender 3 or Ender 3 Pro, and then it bolts in on to the carriage in this weird way that you've got all the clamping force on one side of the plate. And what I'm afraid of is once you start printing things that are heavy and big, I'm afraid that you might have some wobble because the clamping force is not evenly distributed because it's all on one side. And that's why I decided I didn't want to go this route. It's not changing too much, but it is changing enough to where now you're still using the stock frame, but now you're not using the stock y-axis plate or the y-axis carriage, and it's just not distributed evenly. That force is just not staying the same. So that's why I didn't go with this style, but this one right here. Now, I haven't tested the one from Funseer, but the one that I have from Printer Mods works well enough that it's been very reliable. And this is absolutely the same concept. But believe it or not, I actually trust that Funseer's probably done a good job about putting this together. So if we look at like the plate mounting system, it's all aluminum, it's all anodized aluminum, and they even have a kit that looks like it comes with black linear high wind. They do have a kit that comes with high wind, so if we select an 3 Pro, you can get an entire kit for about $90, probably after tax. So actually, hey, that's not bad for 2 high wind linear rails and the adapter and all the screws you're going to need to put it on. So that, I think, is pretty good. So what I'm going to do is, let's see, I don't do the whole affiliate link thing, so I'm just going to give you guys a direct link in the chat to anyone who's interested in getting this rail. Now, like I said, I haven't tested this one personally, but I have one that's the exact same concept, and it does a good job. So that's the y-axis. Let's talk about some other options for the x-axis, because every axis, if you're going to do linear rails, you might as well just go the whole 9 yards and do the linear rails on every axis, because eliminating the use of the V-slot rollers are just not very reliable. So I think this is what I'm loading up right now. We're going to wait for this web page to load here. Is a kit that I used once upon a time. If it would be so kind as to load. I know we're connecting to China. It's halfway across the world, but come on. All right. So this is an interesting rail kit because this utilizes the stock frame, but it's doing something different. I actually do have a full review of this specific kit on my YouTube channel, and basically we've got 3 spacers that allow you to mount the rail above the frame on the x-axis, because if you don't, you'll hit the belt with the way this is. And you got the linear rail going on the top of the frame. And the reason this is interesting and kind of important is because if you want to maintain the absolute maximum build plate volume of your printer, this is what you would need to do. Because if you were to do a kit that is bolted to the front of the x-axis gantry here, what you would have is a problem where the linear rail protrudes forward. And granted, it's only like 10, maybe 15 millimeters of clearance that you're losing. But if maximum build plate volume matters to you, you are losing that if you don't go on the top like on this kit. Now, this kit does work well, but for this one, I really do recommend getting a genuine high-wind linear rail. And the reason for that is you've only got 3 mounting points, and they are not at the very ends. So you see how they're all mounted just in the center here. That means the linear rail is just hanging on the sides and can droop a little bit if it's not perfect. Now, bolting it up, it should be fine, but if you get a really cheap linear rail to put there, some of those really cheap linear rails have somewhat malleable metal, just a tiny bit, and if it's bent at all, it's now going to make your x-axis, which should be flat, into kind of a dome, and that'll be reflected on your 3D prints. So if you're going to go this route, you really should get the linear rail that is, in fact, going to work properly. So, hmm, excuse me. But you know what? We've talked about Funseer, and they do make a kit that bolts to the front. I like the front-mounted ones better, just because it is more secure, and I personally think it's more accurate. But I would be remiss if I didn't talk about the entire BVL kit that people seem to like a lot. So, the entire kit that you can get will turn your entire 3D printer or your entire Ender 3 uh, into linear rails all around. And their system is kind of proprietary. It changes a lot about how your frame is set up, how the mounting points for everything is set up. And that's going to limit you in the future for any sort of modifications that may come up that rely on stock rail positions and or stock frame positions and stock frame components. And that can be a problem if you're continuously upgrading your printer, because then if you have proprietary parts, you'll have to design around the proprietary parts, and you have to figure something out to make those proprietary parts work with whatever upgrades it is you're trying to put onto it. So this one's interesting. We've got the linear rails on the inside, which personally I've never dealt with this one, but it's clever because when you use linear rails on the front face of the y-axis right here, you're going to be sacrificing again some build plate volume on the y-axis, because now your x-axis gantry is pulled forward, and there's nothing you can really do about that. You can set offsets, your home offsets and everything, to compensate, so that way when you print, the center of the bed is still going to center up properly. But this avoids that, and I find it kind of funny that they then use the front mount style on the x-axis, which does again sacrifice a little bit of your y-axis build volume. So if you were to get this printer set up and then you were to use the x-axis setup like from Funseer here, you would actually lose no build volume whatsoever by using their z-axis from BVL and the x-axis from Funseer here. So if build volume is very important to you, that is the way to go. But in terms of stability, this is the better way to go with it. You're not going to lose. The printer is going to be more stable in the sense that the load is distributed in a much better manner. So, excuse me. So BVL, these kits, from what I understand, are pretty decent. If you're willing to go with this as an entire system, and you're not really looking to do much of if you're not looking to do much extra upgrading involving the frame and the movements or the motion systems of the printer, this should by all means be perfectly fine. But there's always going to be something down the road, some sort of upgrade that you might want, and that's where proprietary systems like changing this plate over here where everything connects, and then just changing everything about how the or how the z-axis moves could impede upgradability down the road, because now you're stuck in a particular ecosystem that you're just not going to be able to get out of. Excuse me. So BVL is not bad. BVL is not bad. It's a pretty good all around system. If you're just looking to get it taken care of. Now we've talked about a lot of kits, but let's talk about options if you're not going with linear rails. Let's talk about something a little different. Now let me see. What about metal V-slot rollers? Because I have seen them floating around on the interwebs here on AliExpress. I'm trying to see if I can find it. I'm seeing some stuff here. I just want to make sure I'm pulling up the right thing. Do, 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 do. Kind of close to what I'm thinking about, but I think this is like the inverse of what I'm going for. Hmm. Yeah, no. So this is not what I'm aiming for discussion, but it's getting close. Let me just see if I can find the actual thing. Metal 3D printer wheels. That might. Sometimes you gotta just go with really general terms. Ah, here we go. I believe this is more what we're talking about here. So, you know how most wheels that go on your 3D printer that are stock are some sort of rubber, right? And because of that, uh, the rubber wears away over time, and they can even wear a little bit unevenly. And when that happens, you got to adjust the eccentric nut that tightens up the wheels. The problem with that is that requires you to do extra maintenance and make sure you're keeping an eye on that particular thing. And when you're doing that, or when you have to worry about that, it it can lead to some issues with your prints, and then you're scratching your head thinking like, what's causing this printer issue? It's just another thing that you have to maintain and be aware of. Whereas with the linear rail, that's kind of like not the issue anymore. But with these metal V-slot rollers, and I've never personally used them, but it stands to reason that these metal ones probably won't wear away like the ones that are made of rubber or some sort of material that's rubber-like. Now, because this is going to be metal on metal, my personal take on it is you're probably going to have to put some sort of lube like directly on the rails just to try and prevent wearing away, because you've got a harder metal, stainless steel, on these wheels touching aluminum, which aluminum is a pretty soft, malleable metal. And the harder metal is going to wear away the softer metal. That's just how metal on metal contact works. And unless you create a film of some sort in between these rollers here, I can't imagine that this wouldn't wear away your frame rail to some degree. Let's see. John says, have you already discussed this? I saw on AliExpress Triangle Labs Precision Pizio Z Probe Universal Kit. The printers are machine auto bed oil sensor. I have not, but since you brought it up, let's talk about it. So I want to try and make these streams as interactive as possible. Let's take a good look. I'm going to look this up off screen real quick. And then I'll probably bring it back over to the main screen. Let's see. Uh, Interesting. Well, let's take a look and see what we got here. So this is, well, this is the bare board. Let's see, this product is a Z-probe sensor using the piezoelectric bimorphs technology to provide precision auto bed leveling. There's no XMIO sensing, very precise, 0.01 millimeter hot end accuracy. It's interesting. So, okay, that's how it's connected, and then we got three little connections here. And then, okay. I'm not really seeing anything about how it actually works. There's some pictures of receiving the product. Huh. I wonder if we can find a picture or a video of this thing actually working. I know there was a YouTube link. Let's try to open this as. No, I think I may just have to copy pasta like that. I'll watch and how it's. Huh. Well, I think this falls under fair use looking at this. So let's take a quick gander at this, and I'm gonna speed this video playback up so that way we can all take a look at it together here. Because I'm trying to figure out how exactly this works, because I've never personally seen this before, but hey, new things are cool. Now, I do have the audio turned off, uh, just because, you can't really. One, there'd be audio feedback on this stream if we were to just do that, but it looks like some sort of sensor that detects when the hot end is touching something. So it's not entirely clear what's going on, but it perhaps there's some sort of hmm. So when it bumps something on the ground, it triggers the sensor. But I wonder, it doesn't look like it's like a pressure sensitive thing. I wonder if it has something to do with perhaps magnetic fields. But there's certainly looks like there's a way to adjust it. Interesting. Very interesting. My guess is the way it looks, it seems like as if the moment something on the hot end touches another thing, that registers a signal and says, hey, that's the position where we're touching something. Which seems kind of like what Creality is doing. Uh, but no, but Creality's solution actually seems like it depends on flexing something to make that work. This is interesting. I've never seen a sensor like this. The only thing that worries me about sensors where you're required to touch your hot end to the bed. is when you're probing your bed, the bed's hot, and sometimes your nozzle is hot too, depending on how your probing setup is. So you got your hot nozzle poking directly onto the bed. Now, preferably, you'd be printing just barely above the bed to just get a tiny bit of squish on your first layer. But the bigger problem I have is there's a lot of systems nowadays that rely on super thin heat breaks to prevent heat creep from going upwards into the heatsink and causing a clog. And it's usually made out of titanium, and titanium's a really brittle metal as it is. It's strong, but it's brittle. And the moment you start poking that thing onto your bed, if the sensor isn't like super gentle about it, you really do stand to break your heat break by doing that. And I'm just wondering if the stress that can happen on that particular component over time could break it by doing that. Nevertheless, this is really cool, and I actually would love to see how this pans out as things progress. But it looks like it requires you to use. This might just be a mount, honestly. I don't think it specifically requires that you use that mount. It doesn't look like it. You know, the mount's just plastic. It's just a way to hold something in, I think. But, auto bed levelers. That is a hot subject we could get into at some point. Maybe that, you know what, I think maybe the next stream, we'll start talking about auto bed leveling systems. Because that has a lot of different options now. And I think that would be a great rabbit hole to kind of just dig into, because man, that one can get pretty deep as well, especially when you start going with certain. There are certain companies out there that look like they blatantly rip off other companies that have closed IPs, and it's just like, oof. I know. As of right now, like companies like TH3D, like they're about to release their new motherboard, and they're not posting any pictures of it until it's actually ready to be shipped out, because they've had problems in the past where people have looked at their boards, copied it, and then made it and sold it before they were ready to sell theirs. And I'm like, dude, that sucks. Oh, but while we're going down this rabbit hole, we've talked a lot about linear rails. Why don't we talk about another thing that's also really important to the function of the motion on your 3D printer? The belts. I think the belts probably gets overlooked a lot. Now, when it comes to belts, Gates, genuine Gates branded belts. Gates is very well known in a variety of industries for making pretty decent belts. Timing belts for your cars, machinery, and even belts for your 3D printer. Now, the important thing about belts like this is that instead of just being a simple rubber compound that's molded into a shape, these are fiberglass reinforced, meaning that throughout the entire strand, there is a continuous string of fiberglass going all the way through it. And the reason the fiberglass is important is because the fiberglass does not stretch. It can bend, but it does not stretch. So that means that the rubber, which can stretch, since it's reinforced with the fiberglass, it shouldn't stretch. Also, when you start to use metal belt or any sort of belt tensioner system, you're pulling that belt apart essentially to create tension. And because it's fiberglass reinforced, it shouldn't stretch. And that also makes it stronger, so it shouldn't just snap either. So you can keep your belts nice and tight, not too tight, because then you can bend other components like the shaft of your stepper motor where the pulley gear is on. But it'll allow you to maintain a consistent amount of force to keep the belt taut. Whereas non-fiberglass reinforced belts, they'll stretch, and then you'll have to adjust. And then it's another thing to worry about. So if you're going to get a new belt, do yourself a favor. Get yourself a Gates-branded fiberglass reinforced belt. German says, "Lol belts. I just bought the Sunlu S8 Plus plastic POS belts the thing came with." Yeah, man, I tell you, when you're going for cheap printers, they use cheap parts to keep the price point low. There are just some things that are worth getting. However, this brings up another topic which involving belts, which I think we need to talk about since we're talking about fiberglass or any sort of reinforced belt. Okay. If we can look it up. Aha. This. You don't want to use this. This is a steel core belt, and it is the exact same concept. The difference is that this doesn't use fiberglass continuously through it. It uses a steel core. Now, you might think to yourself, hey, steel, that's stronger than fiberglass. And in tensile strength, perhaps, and in certain cases, perhaps. The problem, GT2 GT2 pulleys on 3D printers are typically pretty sharp turns. And the problem occurs with these metal belts, or the belts that have metal reinforcement in them, is they're meant for use on a big diameter pulley gear, or a big diameter gear to go on, right? Sprocket, or no, not a sprocket, but you know what I'm getting at, the gear. And that's because if you use a big round gear, you're not putting a lot of stress on the metal, because if you go to a smaller gear, and you've taken any sort of like piece of aluminum, for instance, and you just bend it back and forth, you'll notice that there becomes a stress point that gets weaker and weaker and weaker until the pieces of metal just fall apart from each other. That same problem happens to these belts. When you're constantly moving them back and forth around a really tight, small diameter gear, the metal starts to fatigue and wear away, and then eventually the metal disconnects internally and you don't actually get any reinforcement. If this was going over a really big diameter gear, you would be okay. But because it's not on a 3D printer, you're just better off getting fiberglass reinforced, because fiberglass doesn't have this problem when going around a really small diameter gear. Alright, Jim says those things. I watched a vid where someone was rebuilding a Sunlu S8 with those noisy things. That dude went back to stock belts. Yeah, I don't know anything about the noise, but I do know that it's alluring because you think metal strong. Not in this case. That's why fiberglass reinforced belts, they do fine. I've never used the generic fiberglass reinforced belts. In some cases, I think Creality is actually using fiberglass reinforced on some of their printers now stock. I could be wrong, but I think I saw it on some of the Ender 5s, because Ender 5s are Core XY, there's a lot more belt involved. And when you have that much belt, you really just don't want it to break. And you want it to be consistent. So consistency, you get it with this type of belt. So John says, so is steel cheaper? Is that why people buy them? So, well, let's look at the price here. Is steel cheaper? That's a fair question. So we got to get some, let's see, what can we compare price-wise? We got to make sure we get the same lengths. GT26 2 meters. GT2. Well, let's see what we can find. These aren't listed the same here. GT26, 5 meters. Do we have a 5 meter option here? These aren't. That's 12 meter, 10 meter, 8 meter, 6 meter, 4 meter, 2 GT, 9 millimeter. No, we want 4 meter, 6 millimeter thick, 2 GT. We're not going to get a perfect comparison here. Let's see what I put over here. It was 4 meter, 6 meter. We're not going to get a perfect comparison, it seems. No, wait, 2 meter, 6, 2, GT2, 6, GT2. Okay. All right. I think this is about as close as we're going to get. So, about $6 for 2 meters of 6 millimeter wide GT or 2 GT belt versus another GT2 6 millimeter wide 2 meter belt. And we're just going to go with the color white. It is cheaper. It is much, much cheaper. Well, there's also shipping here, but I don't know, there's shipping more expensive here. So, it seems for our purposes here, if I've selected everything properly, for as close of a comparison as we can get, the steel core stuff is cheaper, but I think that's not why people buy them. Because the plain stuff that doesn't have any reinforcement is even cheaper than that. I think the reason people get these metal reinforced ones is because they think that metal is going to be stronger and more reliable, therefore it seems like a logical option, but they forget to take into effect the fatigue points that will develop in the metal from constantly being bent around a tight corner, or like, well, I've got my tissue paper that I've been using to blow my nose this whole stream. If this circle's really tight, you know, you're bending metal around it constantly. If you're bending metal around it constantly, it's gonna wear that metal out, where fiberglass just doesn't have that problem. I feel like aesthetics is just not even the case. I think it really is people not thinking about the consequences of what metal is and isn't capable of in this regard. So, as far as your belts go, yeah, stick with Gates with fiberglass reinforced. I've been using fiberglass reinforced for, it's got to be like half a year to a year now. Have not had a single problem with them. They do fantastic. But all right, so we've gone into this. Where else can we go? Anyone got any other subjects we could bring up? Because we could totally kind of just deviate anywhere in any direction at this point. Yeah. Let's see. You know, one. Did we ever talk about? We did the Y and the X axis. We've been talking about linear rails a lot. Let me find another linear rail situation that we can talk about. Because you know one thing I've been looking at. Let's try Ender 5 linear rails, because I've been looking at getting an Ender 5. And with something that moves along like that, I'm just not finding the kit that I thought I was looking for. Well, here is a kit. Let's see. Is this the brand I think it is? It's no brand. Wonderful. It's a no-name brand. Okay. Seems well enough. Okay, and they're giving you a setup for a direct drive or direct-ish drive. Interesting. I don't think... That's not really what I was going for with the linear rail kit for an Ender 5. They're definitely out there, but I'll have to take a better look. SKR, or Superconductor, says SKR GD chip debacle. Let's see. I have not looked into that, but we can certainly look around and see what's going on there. Oh, I typed that in. Whoops, I didn't type that in on AliExpress. I don't know what I just typed that into. Hold on. Let's pull up what it is we're talking about here. Well, the SKR is a board. I might need you to be a little bit more specific. Okay, Superconductor says they substituted a clone processor for an STM, and Marlin is hanging while printing. Ooh. Now that's a spicy subject. Well, we also have John saying, so I know you talked about bimetal heat breaks. Would you recommend bimetal or titanium for micro Swiss to alleviate heat creep? Good question there, John. Here's my opinion on the bimetal thing. I think some companies definitely know what they're doing with bimetal. We're talking about slice engineering, they absolutely manufacture bimetal products properly. When you try to emulate that process cheaply, you run into certain issues. I know that bimetal heat breaks in the past from a lot of these Chinese manufacturers have had problems. And one of the bigger problems is the two metals separating from each other. As far as micro Swiss goes, I really think the titanium heat break on a micro Swiss hot end is actually plenty sufficient for even prints up to like 280 degrees Celsius. I really don't think you'll get heat creep. I do have my parts on Thingiverse that I built around someone else's fan duct. If you have a micro Swiss heatsink, there's a fan duct you can print that holds the fan directly on the heatsink and blows the air directly over the heatsink, much like a V6 style hot end. And actually, let me just pull that up. We can just go on Thingiverse real quick and show you, because that is the easiest thing to do. My profile. And I believe it is my companion mount. And I built my companion mount system. Heat fan ducts. I built it around this guy's design. So the original design for the fan duct for a micro Swiss is this guy. What did I just do? All right, there we go. So this allows you to put a fan directly on a micro Swiss, and they also got one for standard Mark 8 hot ends. So much like an E3D V6, you can have your fan blowing air directly through the fins of the heatsink, maximizing the cooling potential in that area. And when you have a fan working like that on a micro Swiss hot end, I think the titanium heat break is perfectly sufficient to try and reduce heat creep. And I think with a fan on there working like that, I've never run into a heat creep issue when running my system like this. So this fan duct I think is brilliant, and I've been using it ever since. So it is linked in the chat for anyone who wants it. And Ralph Reed says hi all. So hi Ralph, thanks for joining us. Only thing, and German says, only thing I've read about GD32 is that it's not compatible with Clipper firmware. Um, interestingly enough, I've never used Clipper. I've heard really good things about Clipper. The only thing, so when running things from the Raspberry Pi directly to a 3D printer, I've had a single problem that I've been dealing with for literally years now, and it's the cable. The cable is always the problem for me. I always have some sort of problem, especially with a really long print, where the mini USB on a lot of the boards out there for Ender 3s, specifically to like a direct drop and swap, it's still a mini USB. And for whatever reason, I keep having cables that lose connection on the mini USB connection. And then when that happens in the middle of a print, just your print's kind of done. There's no real way to just immediately start that back up. So on critical prints that I know work well, I print directly from the SD card. But when using Clipper, usually people have it running on a Raspberry Pi, and the Clipper does all the calculations and just sends the movement info to the printer via the USB connection. I just haven't had good luck with that USB connection. It keeps getting me. I'm starting to get to a point where maybe I'll just solder a wire in there and be done with it. Because, man, every time the USB connection. Ah. Anywho, Superconductor says at German, there's a USB timing issue due to the processor running at different speed, causing Marlin to hang while printing. Ralph, interesting. I know you can choose the baud rate on a lot of softwares, like when you're connecting your Raspberry Pi to your main board, you got to have the right baud rate. I wonder if that can be edited in Marlin to make it work. But Ralph says, I can't get my micro Swiss to stop stringing. I reduce temp and then it loses strength. So Ralph, first off, what filament type are you using? So if you could let me know if it's PLA, ABS, or PETG or something, I can help you kind of go from there, because there are some things you can do to stop the stringing that I can definitely help you with. German says it's superconductor. He's like, yeah, I'm reading about that now. That's why I try to use UART pins on mainboards. Interesting. That is, you know what? Since we're talking about SKRs, why don't we look up SKR? Do we know what particular motherboard is being affected right now, or is it all the motherboards on the SKR style? And is it a specific brand we're talking about? Because I think SKR might be open source with various brands. We can if we can figure that out, we can bring it up and we can have a cool discussion about that one. Alf says, I'm using PLA Inland brand. Okay. So, few questions with PLA is when you have how old is your PLA and has it been sitting in the open air for a while? Because PLA will get stringy if it just sits in the open air for like a week or two because it definitely absorbs moisture. And when plastic absorbs moisture, it becomes stringy when you print it. So, if that's the case, what you can do is you can get some desiccate, put it in a airtight box, and the desiccate will absorb the moisture. And whenever you're not using that plastic, you can keep it in there, and that'll prevent it from absorbing the moisture and having stringing problems. If you want to get rid of the stringing, you can put it in. You can put your filament in a food dehydrator or even an oven on really, really low temperatures, and that'll help release the moisture out of the plastic. And that should significantly help with stringing. So it might not be your printer at all. It might just be the filament is a little wet. All right. German says that, Ralph, I'm getting that too. I lowered retractions at 25 millimeters. Something helps with PET G. So when it comes to PET G is just always a stringy mess. That is, PET G absorbs moisture really fast in its filament form, and because of that, it's really susceptible to that problem. And all I can say is dry the ever-loving crap out of PET G before printing with it, and definitely store that in a box with some desiccate to keep it dry. Okay, Superconductor said it was the SKR Mini E3D. Oh, is it actually E3D themselves? SKR Mini. Oops, typing in the wrong spot. SKR Mini E3D. Oh, there's an E3. Usually Big Tree Tech that's pumping out the SKR boards. So would this happen to be the one you're talking about, Superconductor? German says, yeah, people don't think that PLA can absorb moisture. Drying will really help. No, any plastic can absorb moisture, especially in its filament stages. And when it absorbs moisture, the diameter of the filament also tends to increase a little bit, which makes it a little less consistent. So that can also cause problems too. But yeah, no, invest in a food dehydrator and it will make your life so much better. Especially if you have really like exotic filaments that just have to be dried. It's easy. You just with the food dehydrator, you just plug it in, plop the filament in the dehydrator, let it sit for a few hours. Then come back to it and then print with it and you're good. But regarding the stringing, I had a terrible time with my Ender 6 Bowden setup, causing stringing due to the stock fitting, letting the PTFE tube slide in and out during retractions. Yes, yes, the Bowden fitting. So you're talking about the pneumatic coupler, I believe. I run a Bowden setup on my printers, and ever since I swapped over to compression fittings, I have never had a Bowden slippage issue since. Every single print comes out great now because my Bowden tube does not move up and down or twist around or slide around. Compression is king. Compression is king. There is not a better solution that I've ever found. So, in fact, regarding that particular thing, I want to bring something up. because I am not the only one who thinks compression's awesome. I gotta shout out one of my favorite brands just because I am a big fan, but also their harshest critic. And let me see if I can get this picture. Copy image address. There we go. I'm not the only one who thinks compression works. Micro Swiss is making hot ends that use compression fittings too. I was, I believe, the first one to bring up the concept, and I had them custom make me some CR10 Ender 3 heat sinks with threads in them so I could put compression fittings in them. And they started trying them out on their end as well. And they liked them. They found them to be really reliable. And it's just like, yes, this. I'm not the. It's not just me. Compression fittings work, man. They work so well. And then, yeah, that comes with. Copy image address. There you go. You got your compression brass compression ring and the nut compression nut up there. They're just starting to make them with compression fittings now because it's the way to go. I'm really hoping they put out a new version of their CR10 style heat sinks to use compression fittings, because once they do that, there is no reason to ever buy a Chinese version over the genuine stuff. Because once Micro Swiss starts using compression on everything, it's game over for the Chinese companies for a while, at least until they start imitating again. All right, back to the comments. Let's see. Ralph Reed says, yes, put a fan in it. Superconductor. Regarding the SKR issue, apparently they sent out boards to distributors to sell before they finished testing. You know, I wouldn't put it past anyone to do that. There's a lot of competition in the board space, and when you're moving things along really fast, sometimes it's let's let the customers be the beta testers sort of situation. Unfortunately, a lot of people deal with that sort of problem in one way or another. I hope that we see a situation. I am pretty sure another manufacturer did something along the lines of offering free replacements, or store credit, or even refunds for the defective parts they sent out that I think were motherboards. So hopefully we'll see something like that again, because if this is a genuine problem, and also we are dealing with a chip shortage issue, I wonder if they couldn't use the chips they wanted to use because they just weren't available, because we're still in a global chip shortage right now, and it might be a situation of try and run whatever you can get, and they put too much stock in the non-genuine part. Let's see. Jordan says, looks like I bought my Microsoft hot ends too soon then. I think it'll be a while before Micro Swiss fully releases a lineup of compression style hot ends. But as it stands right now, if you contact Micro Swiss and you tell them you want a threaded version of whatever hot end they're selling, or even just a heatsink, they will make you one. Or at least they did for me. And I order the only two that they ever made for customers because I was the one who asked them to do it. And I swear I will never go back to the stock anything, because compression, man, it works so well. I don't understand why it's not more popular. Like, I saw it originally in the Prusa Mini. And I'm like, I know what that is because I just did the water lines using similar fittings for my refrigerator. And I thought, that's a really good idea. And I went on AliExpress, and you know what? Hold on. Let me pull up what I used. Ooh, well, I gotta sign into my account here. And I gotta pull up I want to pull up exactly the parts that that I use from my compression fittings. Because if I'm gonna even suggest doing this, then I would rather you guys know the exact parts that I purchased. Here we go. Now, someone did bring to my attention there's probably a better thread option than this. But these are what I used. These are... Well, that's not an accurate representation, but... well, these are the M10 threaded compression fittings. And I basically asked Microswiss, hey, can you make me a heatsink that's your standard CR10 style heatsink, but instead of having a Bowden collet, can you tap an M10 thread in there for me instead so I can use these? And they did. And it worked. And I'm never looking back. So let me put these in the chat in case anyone is interested. Again, that is not an affiliate link. It should not be. I don't do affiliate links. But if anyone's interested. Now, I will say this. There's probably a better thread to use than M10. Probably like M6 or something along those lines. Because that'll hold the Bowden tube a little more rigid in place. But I haven't had a problem with my M10. Apparently, stock threads on a Mark 8 hot end are either British spec pipe, BSP, British pipe spec or something like that, or possibly national pipe thread style threads. I forget, there was a comment, and it turns out that this particular type of taper thread compared to an M10 thread are so incredibly similar that a lot of times they just like they use them interchangeably even though they're technically not. The difference is that basically M10 threads are what a standard Mark 8 hot end has, only think of what the Mark 8 hot end has as a tapered M10. M10's M spec threads aren't supposed to be tapered, so that's why it's probably sort of a British pipe thread spec or some sort of national pipe thread spec, which are tapered. So you could probably find the absolute specific thread for these fittings to go directly into a stock Mark 8. But I just chose M10 because that's what every spec on every pneumatic coupler said was M10, even though they technically weren't. But if you do get these, you could legit just use an M10 by 1 tap and just spin it through and it will untaper the thread and these will just fit just fine. I actually have a video doing all that on my YouTube channel as well. German says, thanks for the links. I'll be tapping out on some cheap aluminum block. See if I can get the threads right. I've got a video that shows exactly how to go about it. In fact, Irwin makes taps. You're looking for an M10 by 1 tap if you're going to use these. Made in America. And they worked great for me. Everything that was a standard Mark 8, I just used M10. But, man, maybe I should pull that up real quick and see, because I am pretty freaking sure that someone pointed out the actual spec, and I would like to get that right. Someone says it's 1/8 inch BSP tapered, not M10 metric. And apparently those two threads are so incredibly similar that 1/8 inch BSP is basically M10 but tapered. So I've been looking for them. You know what? Let me see if I can find in here, because it could be National Pipe Thread, it could be British Pipe Thread. The specs are just slightly different because we're two different countries. We can't have a universal system. That would be too easy. But this is the company I got it from on AliExpress. Let me see if I can find. Here we go. Visit store. Come on. NPT. Okay, they have National Pipe Thread. Fun fact, the M10 listing, that company made specifically for me because they didn't have that listing beforehand, and I asked them about it and they made one for me. Awesome. Okay, hold on. Here we go. We might have, let's see. No, we want for outer diameter fit for tube of 4 millimeters. So no, this one, either that or here we go. Fit OD 4 millimeters. So the outer diameter of your Bowden tube is 4 millimeters. So that's what the top of this is, where the compression nut goes. And then we're choosing the thread spec of 1/8 inch, which is what someone said it was. So in theory, if the person in my comments is correct, this would be the exact one you're looking for. I have yet to purchase them. I do want to purchase them, just so I can test it out. But they're super cheap. I'm going to put the link in AliExpress. Oop, that link is way too long. Hold on, I will have to shorten that link. Let's see, I think I can just remove a bunch of that and still get it. I sure can. All right. That is the link to these compression fittings. Again, you'd be looking for tube for outer diameter 4 millimeters, and according to the one guy that commented, it's 1/8 inch British spec pipe thread. So, if he's right, that should work, and they are literally less than $1 each. Granted, it's $2.26 shipping, and there's probably a little tax, but if it works, man, you'll be set, and you won't have to modify the threads. So let's see. Let me go back to the comments here. Erwin M10 Tap, got it. Found your vid. Cool. German, check the comments in that vid. Some good insights in there. Yep. Superconductor. Will do. Yep. So, yeah. No, I absolutely love it when people point out that I might be wrong about something, because I'd rather have the correct information out there. And the only reason I was like a little confused in that comments when someone mentioned this is because if you go to literally any link or page on Amazon or dude, even Capricorn's website, everything says the pneumatic couplers for a Mark 8 hot end is M10. But it's not, because M10 is not a tapered thread spec. But it's all tapered. So that's what got me confused. But, they bring up a good point. So maybe try that out. If anyone wants to try it out and see if it fits, That'd be awesome. I definitely, I really should just buy it. I mean, it's a few dollars. It's not gonna hurt me to test anything. I gotta see if I still have a standard Mark 8 heatsink somewhere that I haven't modified. I think I've got one laying around downstairs in my workshop. Superconductor at me. Order those and make a vid, please. Yes. I think I'll be doing that. Um, Tell you what, I'll order some later tonight, and but do be aware, with the global shipping situation, it's probably gonna be like a month before, at least before I get them in. But it's no skin off my bones to get these because I don't want to tell you guys to buy something if I don't know if it's actually going to work. But I tell you what, I've got these. I've already got it. I've already got it hearted in my account. So, and also for those of you who are worried about this being a one-time use concept, no, it's really not. So, these are the little brass compression rings. 50 of them is literally $1.20 plus shipping. And the beauty of these things is people think, oh, once you tighten it down, your tube's done. Like, it's actually better because all you do is you remove the compression nut and the tube just pulls right out. The ring stays in place. So that way when you put the tube back in, the ring's already in place and you just retighten it down. And you only got to go hand tight. You don't need to torque it down. And it does not compress the tube. Like, at all. People are afraid because it's a circle compressing, right? They're afraid that it's going to compress like this or like this, like oblong. But it doesn't. It stays a circle, but on the outer side, the center, that center simply bends outward while the inner portions maintain their diameter on the inside. So you're not bending your Bowden tube. You're not kinking your Bowden tube. There is no issue with getting filament through the Bowden tube. It doesn't create any extra resistance. So, because I've seen that comment a lot, and it's just not the case. But yeah, once I tried them out, there was just no going back. They worked too well. And in fact, they're just so reliable that doing any tuning on your printer is so much easier as well, because it's another failure point that you now know is not going to be a problem once you have it set up right. Once it's in there, like, why would you bother changing it, sort of thing. Let's see what else, because actually, you know what? While we're talking about this subject, I'm going to show you what I tried beforehand that did not work at all. These stainless steel all metal pneumatic couplers. Oh, these guys got it right here. G 1/8 inch, similar to M10 thread. Okay, so it does look like one. I don't know what the G stands for, but it's 1/8 inch. Whatever the case may be, these things right here, I tried these and I made a video on them. This is a Triangle Labs product. And boy, howdy, let me tell you, these failed almost immediately. It makes no difference whatsoever that they are all metal. The teeth on the inside still broke. Oh, hey, my friend Michael is here. He's everyone say hi to Michael. He is my friend that's got the copycat printer in the machine shop downstairs. So I personally work on his printer. And so yeah, we've done it on we've done it on his printer because we're like this like that's where the second of the two micro Swiss hot ends that were made went to is he got the second one. So, but yeah, no, these all metal ones are just no better. The teeth on the inside that grip these things still break. These things broke so quick. The thing about it is, you get this, right? And you think because it's all metal, it's going to be better. It's just not. And then look how much you're paying, man. You're paying so much more for this and more for shipping for a product and I'm like I said, I made a video on it. It just broke. It just broke. Versus, okay, you're paying $3.61 for one of these pneumatic couplers, a thing that just does not work for 3D printing in a Bowden tube, versus $2.12 for 5 compression fittings. Yeah, it's just, yeah. But yeah, you know what? This stream's been going for almost 2 hours now. But hey, we've had a good time. Next time I will try to get this stream running on a weekend a little earlier in the day because I know this was late and I know this is a Sunday, so people are going back to work on Monday. So I'm actually going to end the stream here, guys. Thanks for joining. Thanks for watching. Thanks for having fun and interacting. Remember, with the next stream, if you find something interesting, save a link to it and post it up here in chat, and we'll talk about it. Let's make this interactive. If you got, hey, you know what? If you've got 3D printer questions, if you have a problem with your 3D printer, make a quick video of the issue and post a link of it in the chat. Next stream, I'll take a look at the video and see if I can help you diagnose the issue with your printer. And we'll all learn together. So, have a good night, y'all. And I will see you guys on the next live stream. Let's make it a good one. And stay safe out there. And, you know, I got a little cold, so make sure you got some cough drops and some chicken noodle soup. But, yep.